All right, we are going to do our second set of notes for our segments, rays, parallel lines, and planes. Now, those will be very similar to the other notes, a lot of definitions, a lot of pictures, a lot of tedious things that you guys need to make sure you understand and can write. They might seem like it's not important, especially with definitions, but it is very important that you guys understand these for the proofs later to come. So the first one is a segment. A segment is just part of a line, and a line is what we discussed today in the prior notes. So it's just part of a line. And you might ask yourself, why do I need to know what a segment is? I know what a segment is. Well, it's important because when we do proofs, you have to have a starting point, and we have to break everything down into its smallest components, and then we build it up to what we're asked to prove. A segment is a small component of a line, so we need to understand that. It has two endpoints. Now keep in mind, a line never had an endpoint. It goes on and on forever in both directions. But a segment is just a little piece of a line. So it does start and end. And there are points in between those endpoints. So it's not just 2 points. There can be multiple points in a segment. So how we look at a segment, and I'm sure you already know what it looks like. There's our segment. There's our two endpoints, and we say endpoints rather than a start point and an end point, even though that's kind of what it is, because you can go in either direction. So both of them are starting points, and they're both ending points. And that's just the way it is. You can name this with the two endpoints, and you just put a little dash above them, no arrows, because arrows indicate moving forever, and these don't go on forever. Or you could reverse them. Order does not matter with segments, just like order didn't matter with the lines. So now a ray is similar to that. Change up the color. A ray is also part of a line, but it does go on and on forever in one direction. So we say it has one endpoint. I like to call it a starting point, because how do you start at the other end and move toward the end point? So maybe make a little note there. If you can think of starting point when you think of a ray, but just say end point because that's the legitimate term, that would be wise. So if I drew that, it would look very similar to a segment. I can have an A here and a B. Those are, A is my starting or end point. B is the direction in which the ray is going. I like to think of a ray of sunshine, where the sun is your end point or starting point, and the ray goes on and on forever. If you can think of that and it makes sense, great. This would be, this order matters now. This would be ray AB, and you do a single-headed arrow. Now it is very different than this. If you did this, okay, if you had that, this would be called ray BA. But the arrow will still go in the right. The arrow will never go to the left in a name. It always moves to the right. The important thing is that first letter. That first letter tells the reader where you're starting. The second letter tells the reader where you're going. So the arrow here, that little symbol, just tells the reader that it's a ray. Okay, so get these little things out of the way. This little thing up here tells the reader it's a segment. This tells it's a ray, and the letters tell which way the ray is going. That can be confusing because you want to write that arrow to the left because the ray is going to the left, but that would not be correct, and it would get marked wrong, so be very careful. Okay, opposite rays. Now with opposite rays, I like to change colors, make it rainbowy. All right, you have two collinear rays. Remember, collinear means on the same line. Lots of definitions. You might want to get some flashcards, keep yourself straight. that share the same, that word is same, you can see it on your notes anyway, endpoint, starting point, and they go in opposite direction from that starting point. They always form a line. When you put them together, you create one line. So this is what it looks like. If I drew you a picture and I said ray RS, now I'm going to just keep that together and I'm going to add, because I'm going to discuss something here. And I gave you 2 more points, made this a B. Now I have a really long line here with 4 points in between. Now there are more than 4 points on this line, but 4 points that I have designated as points with names in this picture. Now we have ray RS going this direction. Remember, we start with the starting point and tell the reader what direction we're going, but the arrow still goes to the right. And we also have ray RA or RB. They're the same ray because we start with the starting point R and we tell the reader what direction we're going. Well, this ray goes on and on forever, so it doesn't matter if we tell the reader it's ray RA or RB because A and B just tell us we're going to the right, so it doesn't matter regardless. I'll just say RA. And we still put the arrow to the right. If you made these together, going this way and this way, notice we created one long line. Those are opposite rays, okay? However, you're going to get trick questions, so be prepared. You might get a question like R, ray RS, and ray AB, opposite rays. Now the purpose of a question like that would be to see if you know the full definition of opposite rays. Yes, they are moving in opposite directions. That would be correct. However, they can't be granted the name opposite ray because they don't form a straight line. There's that great big gap right here, and there's no gaps in lines, so that's not going to work. So this would not be an opposite ray. So I hope that demonstration will help you out. All right, so naming segments and rays. Now I'm going to give you a picture. We're going to name some segments, some rays, and hopefully you guys will do well with that. So I'm going to draw this picture. L, point P, and point Q. Just some random points on there. This is a test question, by the way. I want you to pause me and I want you to name all the segments that you can find on here. Okay, I'll give you a clue. There are 3 of them. So pause me here, that way you can think on your own for a second. All right, so you should have got segment LP, and make sure you write it correct. You should have got segment PQ or QP, they're the same segment. And there is also the segment LQ or QL. So there's 3 segments there. Make sure you have the non-arrowed dictation on the top. It doesn't matter the orders of the letters for each one because it's a segment and order doesn't matter on the segments. However, order does matter on the rays that we're about to do. So careful there. So naming the rays, you have ray LP. Now you could name these differently, like this could be LQ going this direction. The important part is that you have the L. So if you had LP or LQ, they're the same ones. So I'm just going to put them underneath each other. And then you have a ray PL going in the opposite direction. And there's really no other way to show that one. You have the ray PQ, starting with P and moving in Q's direction. And you have the ray QP or QL. Those would be the same. QP or QL. Same ray. So you should have got 4. Okay, moving on. R in this picture, I have that little note here, always begin the name of the ray with the starting point. We've already talked about that, but are LP and PL opposite rays? So take a look at that same picture we were just doing and think to yourself, are these the same ray or opposite rays? LP and PL. Are those the same or are they opposite? Think about it. Pause me if you need some extra time because I'm going to go on. They are not opposite rays. The reason being is they don't have the same starting point. They have the same letters, but they kind of overlap. Okay? So no, because not same starting point. So don't share same starting point. I'll say end point because that's more appropriate. Okay, moving on to the recognizing parallel figures. Hopefully you remember what parallel is from Algebra 1. If not, it means that lines, they never cross. They share the same slope. If you remember the formula y equals mx plus b from algebra, this m was your slope number. And so anything parallel would share that same slope. Therefore, they would never ever cross. So that's what's going on here. So lines that do not intersect may or not be coplanar. Think about that for a second. Parallel lines, they don't intersect and they're coplanar. So we should say coplanar. That means they're on the same plane, remember that. So coplanar lines that do not intersect. And that's important because we have skew lines at the bottom, and I'm like right below, and I'm going to do that right now just because right here. Because they have some similarities, but they are different too. Skew lines do not intersect either, which is where this little note came from. So they are non-coplanar. So there's the difference, and that's going to be an essay question as well. So non-coplanar. Okay, they are not parallel. And the shorthand for parallel are like 2 backslashes, or some people write the arrows, just because I'll use that as shorthand. Sometimes you can see it right here. So skew lines are not coplanar, they're not parallel, and they do not intersect. But parallel lines, so back up here, sorry to jump around, I just wanted to make sure we had that clear, are on the same plane and they don't intersect. Now, parallel planes are planes that don't intersect. So 2 planes that never cross. So in a box, for example, in this picture right here, 2 planes that never intersect would be like the front of this box and the very back of the box, or the top and the bottom. The top and the bottom, the 2 sides, or the front and the back. And then this question says, name all segments that are parallel to AD. Well, let me label these first. This is A, this is G, back here is J, D, C, I, B, and H. So parallel to AD, so we're looking to be parallel to, let me switch up the color for a minute. Here's AD. Parallel to AD would be any that do not touch and are on the same plane. So GJ, BC, GI, those are all parallel to AD. So all those in red. Now you're going to have to write them on your notes. So write GJ, BC, and HI. Remember, those letters are interchangeable. Now for this next one down here, skew, grab a different color here. Name all segments that are skewed to AE. Well, in this case, this gets tricky. Let's mark our corners. A, D, C, this one's B. Back here is H, E, F, and G. Okay, so label your corners so we can do this. There's H. Oh, it's a really bad H. Let's try that again. That's better. Here's AE. Now skew, not parallel, so they cannot be on the same plane and they're not parallel, so any of those. So this gets tricky. DC, and then we have BC, because they will never touch, but they're not on the same plane. Take some time to digest this after we do this one so you can understand. Maybe grab a box and try and get a better visual of an actual three-dimensional. And HG way back here. So those are all skew. Remember, skew means not parallel. So we could not name any of the ones we named above because the definition of skew is not parallel, non-coplanar, and do not intersect. So they have to meet all that criteria. And last but not least, this is a test question and essay. How are parallel and skew lines alike, and how are they different? So I'm short on time, so I'm going to just explain it and then take your time, pause me, rewind me so that you can write this out. They are alike because they don't intersect. Okay, skew nor parallel lines intersect. That's the only similarity. And when you say this, you have to say it in sentences on the test. Make complete thoughts. Don't say it, because I don't know which one you're talking about. And you can say they, because we're only talking about two things. So they do not intersect. However, they're different because parallel lines are coplanar. Skew lines are non-coplanar. And that's it. All right, so I hope you guys understand this. Now remember, this is here all year long. So right before the test or quiz, if you need to review, this is perfect. Or go on YouTube and upload or search for segments, rays, parallel lines, and planes. You'll get some wonderful instruction that way as well. But you guys have to take the time to find the instruction. Take control of your learning so that you can learn it. All right, anyhow, I'll get off my soapbox again. I'm just trying to prepare you guys for college and for real life. Even if you don't plan on going to college, you still need to seek out information on your own in your job. You have to know how to do this. So anyway, you guys, tomorrow we will be working on page 25. If you're going to be absent, please have it done by Monday. You still will be submitting it through Edmodo unless you finish it in class. Okay, and tonight, hopefully you've already submitted tonight's assignment from Edmodo from 3.1.3. If not, don't forget to do that. Turn in. Okay? You guys have a great night. Thanks a lot.